Hello everyone. Today we are going to start the new topic Current Electricity Grade 12 exercise. My name is Professor Shreya Sawan. So let's see. The questions say in a following circuit diagram, the infinity series of resistance is shown. The equivalent resistance between A and B. Okay, so in that consists we have an infinite series of resistance. It means the 1 and 2 ohm, 1 and 2 ohm are continuously these combinations up to the infinity. So this 1 ohm, 2 ohm, 1 ohm, 2 ohm, that parameters are nothing but the equivalent resistance. So we just modify that circuit, that is 1 ohm parallel with 2 ohm, okay, and this whole parameter again get repeatedly, so this is nothing but the equivalent resistance R equivalent. Okay, so circuit is extend infinitely to the right and it's symmetric. The equivalent resistance of resistance after the first branch is also equivalent. That's why I'm writing this whole circuit is nothing but the R equivalent. So we have to calculate equivalent resistance across A and B. We know the rule that if the resistance are connected in series, then simply you have to add. If the resistance are connected in parallel, then you have to use the formula 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. Okay. So first we calculate resistance 2 and R equivalents are connected in parallel. So we use the parallel resistance formula. So parallel resistance formula is parallel resistance formula. Okay. So in that 1 upon R dash, this is R dash is a combination of this parallel resistance is equal to 1 upon 2 ohm plus 1 upon R equivalent. Okay. Now we can do solve by cross multiplication. R equivalent plus 2 divided by 2 into R equivalent is equal to 1 upon R dash. So therefore R dash is equal to exactly reciprocal R equivalent upon R equivalent plus 2. Okay. Now we have to solve this resistance. This combination is total R dash. Means now the circuit get modified 1 ohm and connected with this R dash. And this is across A and B. Okay. So now that R dash and 1 ohm are connected in series. So finally R equivalent is equal to 1 plus R dash. Now we just put the value of R dash 1 plus 2 into R equivalent divided by R equivalent plus 2. Okay. After that again do cross multiplication. 1 multiply this whole denominator, it is the same answer R equivalent plus 2 plus 2R equivalent divided by R equivalent plus 2, which is equal to R equivalent. Now multiply this denominator with that component of LHS. So R equivalent and R equivalent, it become R equivalent square plus 2 into R equivalent is equal to R equivalent plus 2 R equivalent. So answer is 3 R equivalent plus 2. Okay. So this 3 to R equivalent comes to here, it become minus. So R equivalent minus 3 minus 3 plus 2 minus 1 R equivalent and plus 2 comes to here, it become minus 2 is equal to 0. Okay. Now this is a quadratic equations. We have to solve that minus 2 is a multiplication of the two components. So either it is a minus 2 multiply with 1. Minus 2 ones are minus 2 and their addition is minus 1. So the answer is R equivalent minus 2 in one bracket and R equivalent plus 1 is in another bracket. So R equivalent resistance is equal to 2 ohm or R equivalent is equal to minus 1 ohm. But the resistance value is not negative. But the resistance value is not negative. Resistance value is not negative. Hence, we consider only positive value. So finally, R equivalent is equal to 2 ohm. Okay, this is the final answer. R equivalent is equal to 2 ohm. So this is a multiple choice question. Let's select which option is right options. The option number C is right answer. R equivalent is equal to 2 ohm. Hope you understood very well. Thank you and all the best.